Okay, so I'm back with another quick little video on how to kind of set up and configure a few extra kind of things. So the primary things that I kind of saw after going through big grading that I thought we might want to go over a little bit more, which is how to go about configuring our layer 3 switch, looking at EIGRP configuration, and also DHCP configuration as well was another thing that I thought we should kind of go over. So let's go ahead and get started. I've got just kind of a short kind of little setup here. Haven't done too much on anything yet. Besides, I just put IP addresses on ISP and on Edge. Haven't touched anything on any of the other devices. So let's go ahead and get started. So first things first, probably make the font just a little bit bigger for you guys. I'll go 12. Just make it a little easier to read. And what we're going to start with here is getting into the configuration for our layer 3 switch and for our switch at this point as well. So whenever we're kind of starting and kind of getting this configuration going, what we need to note and kind of go through is it's the same kind of setup of what we've been doing for our other configs. So we're going to start with going into our global configuration mode, and very first thing whenever we're working with VLANs, always make sure that you create your VLANs first. And we are also going to get in the practice of utilizing that native VLAN, so VLAN 88. So remember, once you create your VLANs, it's always a good practice to make sure that you initialize them as well, so bring them up. So just by going into int VLAN 10, it brings them up and functioning, and so that's what we want to do. After that, now we're going to go into our configs. We're going to say start with FA01. I'm going to say switch port mode trunk, switch port trunk allowed, and we're going to specify what's allowed to trunk on this line, so 10 and 20. I'm going to set up our native VLAN, which is 88. Oops. Switch port trunk, native VLAN 88. And then I'm also going to shut down this interface real fast, because if I don't, I'm going to start getting spammed with native VLAN mismatches. So I'm going to bring that back up here a little bit later once I get core configured. And then the last thing that we want to set up is switch port no negotiate. So if we look at our configs, we've got our trunk mode set. Everything else is configured on our trunk line, so we're good to go on that trunk. Next thing that we're going to set up is our access ports on FA02 and FA03. So we're going to go ahead and do that. We'll say exit, we'll go into int FA02, we'll say switch port mode access, and then we'll tell it what to access, so switch port access VLAN 10. And then we'll also do the same thing on FA03 as well. And we're going to set it to switch port access VLAN 20. Okay. So now that that's configured, while we're here and while we kind of have this set up, it's also probably a good time to just go through, I know it wasn't on the docket, but go through STP again and kind of just show you that configuration. So first thing to kind of look at is we set up spanning tree, and then we specify our mode, and this is from global configuration mode. And we are going to pick rapid PVST. And then the next thing that we're going to do is we're going to go into a int range. And we can do an int range because what we're applying on FA02 and FA03, even though they're assigned to different VLANs, the configuration is going to be the same. So we can put the same configs on both of these, and that's a-okay. So what we're going to do is we're going to say spanning tree, and we're going to put port fast on it. And remember, what port fast does is it allows these interfaces to go immediately into that forwarding state, rather than having to go through the full process of listening, learning, and then forwarding. So it can just immediately jump to that forwarding state and start sending traffic again. We can only do this because these are access ports. If we set this up on trunk links, it can cause temporary bridging loops, which is not a good thing to do. That can cause some network issues. So don't do that on trunk links. So port fast only goes towards end devices, so on access ports. And then the last thing that we'll also want to do is our BPDU guard. And again, and we're going to turn it on, so BPDU guard enable. And remember what this does is it stops those spanning tree messages from being sent out towards devices that don't need to know about them. So again, very similar in essence to our passive interface command is what we use the no negotiate, or what we use the BPDU guard command for. So now that we've gotten that set up, let's go ahead and kind of move into the next aspect. So everything's all configured there. So let's go to our layer 3 switch and go over that config. So very first thing, again, we're working with VLANs, so make sure that you create and initialize your VLANs as well. So we'll say int VLAN 10, 20, 88, so all of our VLANs are up and functioning. And now the next thing that we're going to want to do is to make sure that we turn on our layer 3 functionality. So remember, our layer 3 switch starts out only as a layer 2 device. So it has layer 3 capabilities, but by default those aren't turned on, so we need to manually turn those on. And to do that, we use the IP routing command. Remember, when we say turn on layer 3 capabilities, it just says, I now know what to do with an IP address. I know what to do, and I can have a routing table. So I understand where IP routes go to, what networks are, so it understands the full up to layer 3. So that's what we mean when we say we're turning on the layer 3 functionality. So now that we've got IP routing turned on, the next thing kind of set up is our VLANs, and what you'll see here is I kind of put a little hat on our switch, on our layer 3 switch, and that's to kind of logically help you remember that the bottom half, the point that's going down to another switch, treat it just the same as if it's another switch. So still layer 2, everything that you're looking at is still configured just like a normal switch. Everything up above that little hat part is to symbolize the router that is going to be using, and that is going to be, say, like, treat it like a normal router to router connection between those 2 points. So how we've got this configured now is if this bottom part is going to be the actual, say, like a normal layer 2 device, and I only have one interface, FAO2, where do I put my VLANs, or where do I put my IP addresses for the gateways? And they kind of gave it away there. We put them on the VLANs. So the VLANs themselves are the gateways for those networks. So we'll go into int VLAN 10, and we'll say IP add, and I'm using 192.168.10.1, and it's just a /24, just to make it easy. And then we'll go into VLAN 20, and we'll apply the gateway address for that network as well. So that's where our gateways exist. So the VLANs are the gateways for their individual networks. So we're going to go back, and we're going to go into our FA02 interface, and we're going to go ahead and configure that interface. And remember, it's connecting down to a switch. It's still a layer 2 connection, so we set it up like a trunk link. But keep in mind, if I type in switch port mode trunk and I press enter, it's going to give me an error. It's going to say, hey, we can't do that. You're not in the right mode in order to switch away. A layer 3 switch is just smart enough to know that there's more than one type of encapsulation method for trunking. So it goes, well, what do you want me to do? How do you want me to construct the frame? And what is the proper way to construct that layer 2 header? How should I do that? And so what we need to tell it how to do is exactly that. How to structure and what method we're using between all of our devices. So we'll say switch port trunk encapsulation, and then .1q is the way that we're structuring our frame. That's the specific protocol to say this is our trunking method. This is where we're placing the VLAN tag in that layer 2 header. So we set up our switch port trunk encapsulation .1q, and now that we've done that, we can say switch port mode trunk. And then we'll go through and do the same things that we did like a normal. So we'll say switch port trunk allowed. We'll specify VLAN 10 and 20. We'll specify our native VLAN, so switch port, not track, switch port trunk native VLAN 88, and switch port no negotiate. So if we look at our configs for that interface, we can see our FiO2 should be all set up. So now if I go back to my other switch over here, I should be able to turn this port back on. So we'll go back into int FA01 and we'll say no shut. And that should bring that port back up and everything should be all hunky-dory. And then the last thing that we're going to do too, because I use rapid PBST over on the other side, it's good to say that we do put it into the same mode as well. So we'll say spanning tree mode rapid PBST. So always good if you do it on one side, make sure that you do the exact same for all the others. So now that we've gotten that configured, the next thing to kind of look at, fast forward just a little bit, is let's test and say, hey, did this actually work? Are things actually functioning? And what I mean by that is if I go to these PCs and we put static addresses on them, what should happen is I should be able to communicate between these two devices, because our layer 3 device has a routing table now and it understands where to send traffic. And the first one fails typically because of, ARP hasn't been built, but the second one is successful, and so we know that traffic is working. And we can show that as well by, if we look at our routing table, we can see that we have two directly connected networks, and we can see that they're connected off of VLAN 10 and VLAN 20 there for us. So that's pretty helpful for kind of going through that stuff. So the next part that we need to configure is, now that we know that everything is working down below here, we also want to configure up above and make that routing connection between those 2 points. So we're going to go into our int FA01, and remember the default state for this is all of our ports are switch ports. So they're layer 2 ports. We can't put an IP address on them. So because we need to be able to put an IP address on it, we say no switch port, and that turns that port into a layer 3 interface. So no different than a router. And now we can put an IP address on it just like we do with a normal router. And so same thing. Now if I ping between these two sides, everything is successful. So wunderbar, things are working. Next thing to kind of look at is, let's set up EIGRP. So for EIGRP, again, it's no different whether we're on a router or a layer 3 switch. Both work just fine. For setting up EIGRP, we say router, EIGRP, and then we need to specify our autonomous system number, and this number needs to match across all devices that are using EIGRP. So for this case, we're just going to keep it easy, and we're going to say router EIGRP 10. You can kind of think of it like the area number in OSPF. If the area numbers don't match, we don't have adjacencies forming. Same thing, if the autonomous system numbers don't match, adjacencies will not form between two routers. So for configuration, again, pretty similar in essence to what we set up with OSPF. You advertise all the networks that you're physically touching. So we're going to say network 10.0.0.0, and remember we use our wildcard address, and there are no areas in EIGRP, so we don't have to specify an area. And then we're also going to be setting up our other networks, which is our 192.168.10.0 and our 20.0 networks as well. And now here's another thing to kind of go, is because we've placed our we're utilizing the layer 3 switch, we also want to put passive interfaces on these as well, but we don't want to put passive interface on FAO2 because that's not actually our gateway. So instead, we place the passive interface on the gateways, and in our case, that's the VLAN. So we'll say passive interface VLAN 10 and passive interface VLAN 20. So that should configure that, our core device. So now we're going to go into Edge, and we're going to do the same thing. We're going to say router EIGRP 10, and then we're going to specify the networks that we're physically touching. Now the one thing to note here is that the network going out, that 50 network, is going to be our public network, so we're not going to advertise that. EIGRP, similar to OSPF, is a interior gateway routing protocol, so it only works on our internal network. It doesn't and is not supposed to work on the internet, so you can't advertise public networks over this protocol. So it would work if we advertise public networks in Packet Tracer, but if we do it in the real world, it'll break a lot of stuff. So just get in the habit to, whenever you see a public address, don't advertise it no matter how much you want to, at least not with an interior gateway routing protocol. So the only network that we have to tell this device about is our little point-to-point network. And you can see as soon as I put that network in, a neighbor adjacency formed between edge and core, because we are using the same AS number of 10 between those two devices, and we're sharing those two things, are the same network or directly connected network, and our hello and dead timers are identical as well. So all those things need to match in order for us to form an adjacency between our two devices. So now that I've got that up and running, if we also want to make sure that we set up, say, a route out towards the network. And the way to do that is pretty similar in essence to what you did with OSPF, but just a little bit different. So we're going to say IP route. We're still going to use our default route, and we can point out our G01 interface going towards our ISP. And then once we go back into router EIGRP, we use, instead of the default information originate command, we use the redistribute static command. And that command is what we'll use to actually share that quad 0 route to core. So it just says, hey, if I have any static routes, just take them and rebroadcast them over EIGRP. And then the final thing that I forgot to put on is our passive interface. So we do want to do a passive interface, but we're going to place it on our G01 because we don't want to send out EIGRP update messages out towards our internet service provider. So always a good thing to kind of block that off there as well. So now that we've got that all set up, what we should be able to do is, if we look at our routing table, we can see that we do have a couple of EIGRP routes for the 10 and 20 network. And if I go down to core, I should have a quad 0 route, and I do, so all traffic is functioning right now. So right now I'll be able to get all the way out to ISP, but unfortunately traffic won't come back right now because I haven't done anything on ISP. But that's the general gist. So the next thing that I want to go over, and kind of the final thing here, is DHCP configuration. So where we're going to place DHCP is on our edge router. So we're going to go back into conft, and the first thing to always remember is, if we're setting up DHCP, you always want to start by your start with your exclusions. So specify what range of addresses we don't want to hand out. So we'll say IP DHCP excluded dash address, and then it's a range that we're putting in here. So I'm gonna put in 192.168.10.1, and let's just say I don't want to hand out the first, say, like 5 addresses, so 1 through 5. And then we're also going to do the same thing for our 20 network as well, because edge is going to be the DHCP for both the VLAN 10 and 20. Now that we've set that up, we're going to set up our DHCP pool. So we'll say IP DHCP pool, and then we want to give it a name. We'll just call it VLAN 10, and then that'll put us into the DHCP configuration here. And from here we have really a few different things that we can specify, but there's only 2 primary things that we need for DHCP to really function. The first one is the network, so we tell it what range, how big our pool is. And then the second thing is the default router, which is to tell the device asking for an IP address what its default gateway is. So you need those 2 things at a bare minimum for DHCP to function. So we're going to start with network, and because this is for VLAN 10, I'm going to say our network is 192.168.10.0, and then it'll ask for a network mask. And then the next thing that we're going to place here is our default router, which is just to say what the default gateway is, and that is the address that we set on VLAN 10 on core, which is 10.1. And then we're going to do the same thing that we did for the other ones. So we'll go into IP DHCP pool, and we'll call it VLAN 20. And same thing, we specify the network, and we specify the default gateway or default router for VLAN 20. So if I take a look at my configs and we do a show run, we can see our exclusions, we can see our DHCP pools. So now you'd think, okay, well, is DHCP going to work? Not quite yet, because remember, when I set up a DHCP address, or when my device comes out to ask for a DHCP address, it sends that out as a broadcast message, and the furthest point a broadcast message can go to is our gateway. So if it's beyond, if the DHCP server is not in the same network or broadcast domain as that other device, it won't be able to make it. That message will never be heard by the DHCP server. So we have to help it, and that's where we come in with the helper command. So the IP helper command is always placed where you want to forward, or where you want to catch that broadcast message. So, and where we want to catch it is the furthest point the broadcast message can go to, which is the gateway. So, and our gateways for core are VLAN 10 and VLAN 20. So we'll go back into conft, we'll go into VLAN 10, and we'll use the IP helper-address command. And then the IP address that we're placing here is the IP address of the DHCP server. So we're saying, so remember what's happening with when this broadcast message makes it up to here is the core device will see that broadcast DHCP message, that discover message, will look at it and go, right, I can't forward to you as a broadcast message, so it rebuilds the entire layer 2 and layer 3 header and needs to know where to forward that off. And part of the layer 3 header is the destination IP address, and so that is the address that we're putting in right here. So it says, hey, if I need to go somewhere and I'm sending this up to a specific device, I'm sending it to the IP address of the DHCP server. So whether it's our next hop or whether it's like 5 routers deep, it doesn't matter. You're just placing the IP address of the actual DHCP server right here. Our case, it's just right next to us. And then the final thing, we'll do the exact same thing on VLAN 20, and it's the exact same command because we're also it's the same DHCP server for the two of us. So we should go back. If I plop that back to DHCP, I get an address. It was successful. Do the same thing over for our other PC, and it works just fine as well. So hopefully that was helpful. Again, if you have questions, please let me know. I am going to be having my office hours today from 3:30 p.m. Until 4:30 p.m. Today being Friday the 12th. So let me know if you need any help or if you have any questions. Alright, thanks.